Let's add a little bit more detail about the processes that models want to capture. Obviously, you have weather models which are different than the climate models. There are details that we will not go into. Weather is not so dependent on the ocean and its low memory, for example. You just do it on a few days, so you just rely on the atmosphere and the fast responding land and soil moisture and so on, and aerosols, etc. Whereas when you do climate for multiple months, seasons, years, and decades, you cannot ignore the ocean, and eventually, on a very long time scale, you also have to include land ice sheets, sea ice, and carbon feedbacks, right? So this is a typical kind of plot we always show about spatial and time scale of weather systems and climate phenomenon. So again, not really Earth system and biogeochemical carbon feedbacks. So time scales again go from in seconds, from 1 second to basically decades and so on. And you have spatial time scales here going from meters to planetary scales, 100,000 kilometers. Multiple times you can do that, and so you go 1 hour, 1 minute, 1 hour to 1 century. You have scales of thunderstorms and showers which pop up quickly in minutes and occur in hours, so you need to resolve those by having your grid size to be high enough to capture those, which means running them globally for longer than few hours or a few days can be problematic. Severe storms like cyclones, for example, fronts and tropical cyclones, highs and lows, especially at mid-latitudes where these systems can stay for a long time and give you weather systems that last for 10 days, as opposed to tropics where weather systems are typically very fast changing. Monsoons, West Africa, India, Asia, Australia, South America, North America, and so on. Things like Madden-Julian oscillation, which are moving intra-seasonal timescale processes, so they are less than 3 months, so they are called intra-seasonal. El Nino Southern Oscillation, which is an interannual timescale, so occurs on 2 to 7 years. You have decadal climate variability we talked about, like the Pacific decadal variability, Atlantic multi-decadal variability, North Atlantic variability. There is there's an annular mode in both hemispheres, and so on and so forth. And then we have global warming, of course. Remembering again that we need to worry about Earth system processes as well, then those time scales and spatial scales also have to consider not just atmospheric turbulence but also volcanic eruptions, earthquakes which can create perturbations, seasonal vegetation cycles, soil erosion, mineral and fossil fuel development, soil development, ocean circulation, extinction events, changes in atmospheric composition, glacial periods, and so on. That's where the various models come in terms of reconstructing past. So this is the one of the examples of a reconstruction of the last glacial maximum sea surface temperatures which happened about 21,000 years ago. So reconstructing the past patterns of climate just from observations is not at all easy, because you have evidences gathered from ice cores, lake sediments, marine sediments, corals, tree rings, etc. And they are all local data. These spots you see here as little squares, that's where data is collected. There has been a long-running program called International Ocean Drilling Program. Now the name may be different, where people go and collect ocean sediments, just like they've been collecting ice cores from Greenland and Antarctica and some other places like Himalayas and so on. But we know that from looking at various evidences of glacier moraines and cold water and warm water species of phytoplankton, and so on and so forth, that the last glacial maximum had ice sheets coming down all the way into New York, as I mentioned before. Long Island is in fact a terminal moraine, which means it's a island created by the debris that the ice keeps scouring the earth and pushing ahead of it. And you had also the so-called Fenno-Scandinavian ice sheets coming down into Europe and so on, and of course that would have had large impacts on ocean circulation, the ITCZ, ocean temperatures, etc., etc. So you can see some evidence, some efforts to reconstruct LGM SSTs as anomalies with respect to some base period. Reconstructing absolute temperatures is not that easy, even though there is one map called CliMap which did that. Lots of uncertainties there, but you can see that there were temperatures as colder than 10 degrees compared to modern times, places which were warmer. So just like global warming, you have non-uniform SST responses associated with the last glacial maximum. So these are the modern biomes, and these are the LGM biomes. Okay, so if you just look at the shift in the vegetation, that obviously corresponds to these ice sheets on land that would have completely shifted, wiped out some of these just buried under glaciers, or made things so cold that species couldn't survive. For example, down here also there are a lot of changes which are clearly ahead of the ice sheets, but they would have been suffering from cold, dry temperatures and less precipitation and so on. There would have been shifts in the monsoons, both in Asia as well as Australia, Africa, and so on. Okay, so these are the kind of situations you are dealing with. This is looking at reconstructed changes in vegetation and temperature at the last glacial maximum. So you take these two pieces of evidences and you try to reconstruct these. So again, this is showing anomalies. So the mean atmospheric temperatures, last glacial maximum delta, which is the anomaly, and you can see a mean atmospheric temperature. So you can see that the evidence in the other map kind of matches, which it has to if you did a good job, although there are always differences. So you can also see that there are some issues. So mean annual temperature here, how can it be so heterogeneous? Those things have to be explained. Okay, so when you mix biological geochemical proxies, then obviously SSTs and surface temperatures can be different because of the land-ocean contrast we expect, but estimating uncertainties in these things is always tricky. Just to conclude that, let me not stop here. The reconstruction of the global thermohaline circulation has been even a bigger challenge, but efforts have been made. Valiant efforts. This one is using something called neodymium. You can see this neodymium isotopic composition, and its variability is used to estimate deep water temperatures. So this is at 1500 meters. Obviously thermohaline circulation is mostly a intermediate and deep water circulation. That's what you want to figure out. We will see later on how this is a big player in trying to understand the variability of glacial to interglacial CO2 changes. When we looked at the Vostok ice core record, the sawtooth temperature record with high CO2 during interglacial times and low CO2 during glacial times, how did the CO2 actually change so much? There are multiple theories we will come to, but one of the things we will learn is that Southern Ocean probably played a bigger role. So a program called GeoTraces, which is a follow-on to something that existed before called Joint Global Ocean Flux Studies, JGOF, I think. You can look it up. So that tries to understand all these processes that affect the benthic fluxes, archives that you find, and internal cycling, including water mixing ratios and regeneration, so biological processes like scavenging and what gets sequestered in the sediments, what gets regenerated in the water column, what happens at the ridges, what happens at the boundary exchanges at the continental margins, in the deeper shelf and the upper shelf, how the dust deposits iron and other essential nutrients into the ocean, and so on. So we will come back and learn a little bit about models, add a little bit more detail that to the words that we already used, like grids and grid sizes and so on, and look at the processes that actually go into the models. Okay, so I hope I'm not going too fast. Actually, I'm trying to pace myself, but if there is any issue, hopefully you can play the podcast and understand, or you can message me again.